talking about 160 years back. So that is also one way of GIS potential. But actual GIS has come into picture when with the computers. That is called Canadian Geographic Information System. That Roger Tomlinson, as I said, father of this thing. So he has used for analyzing Canada's national land inventory. So that was the beginning. So later on he has become popular and became a father of GIS. So then we have a Harvard lab, it is very famous, that is Computer Graphic and Spatial Analysis by Howard Fisher. So he was also involved earlier in the SciMap, Synergic Mapping System, that is basically using for certain type of application. So he was there, and then later on using at CSGA. So then another development is DIME. That DIME development is something like a data format, digital independent mapping encoding, that is. It is done at the US Bureau of Census, and then that is Electronic Cartography Union in London. So they also developed, and then you can see that the first ESRI that what I say is this is the first commercial organization. So then you have an Intergraph, that earlier it is called M&S, and then laser scan also. These are the basically US, and then you have UK, first commercial setups. And then IBM also is involved in the development of GIS applications. So that time they use the Geographic Information System, GFIS. And then in USA they have Minnesota Land Management Information System. So then USGS developed a DLG spatial data format. When you convert into digitization, so USGS has developed a DLG spatial data format. ERDAS was founded in 1978. Odyssey GIS, the first modern vector GIS. So this is the first vector GIS. And then ISRI launched ARC Info in 1981 or 83. So then GRASS, this is the open source software. It is basically GIS and image processing software, which came in 1985. So then MapInfo came 1986. So, and then you have first Principles of GIS book, that is Burroughs book, has launched in 1986. And then you have International Journal of GIS, SPAN software, Idrisi software, and then you have a topographically what I say integrated geographically encoding and restoring. So this is a basically topological data structure came into picture in 1899. When you say that it will be discussed later on when it vector data models. So it is the beginning of that vector with the topology. And the National Consortium of Geographic Information Analysis, basically they are involved in curricular development, what is required at university level, etc. MG is something like a modular graphic environment, so that is product of Intergraph, and then these are the softwares came 1989. So then if you go to that 1990s, so Magarin Goodchild book, this is a big book we call. There are two books, you can also call a Bible of GIS, so you can use these books. And then PCGIS, you can say that around 1995 or 93. So that time PCGIS has become popular. So because it is basically reducing the cost and then affordability. People can afford to do that. Earlier when you talk about a computer, it is talking about the crores of rupees. So at least it came into the lakhs of rupees at that time. So then people can afford and buy and then use it. And then expanding the GIS potential. And the multimedia GIS, as I mentioned earlier, it is something incorporating video, audio into this. And then you have an internet GIS, web GIS, where you talk about publishing your GIS and allowing people to refer to that information. Like you have a Google Earth or Microsoft Virtual Earth, and then you have a mobile GIS. You have seen that, Bharat has shown that. Location-based services. You use a mobile GIS for using services. You go to any field, and then or you're in an emergency, you can call the doctor using the mobile instrument. They locate you where you are there, and there is an accident. So these location-based services can be used. And then open source to satellite image, that is a Google Earth. Another important thing is availability, applicability, and accessibility. So this is a policy issue, so that also plays a role, important role. So earlier people are not able to get effort to get a satellite data because the Google Earth came, so then it is easily available. So similarly, if somebody can view that, so it is a great advantage. People, there is a lot of discussion, is it a tool or science? So let us skip this, but it is, people earlier say that it is school, later on one school thought that, school of thought is that it should be a science. So because there are so many issues are there talking about GIS related to science, so that's why it is called a science. So let us also discuss about the technological trends. You have seen that your earlier module also, you are talking about multispectral data and then hyperspectral. There is few number of spectral bands, and then you have more number of spectral bands, and then you talk about the data like a low and high spatial resolution. So till 1995 or so, you have a spatial resolution, we are talking about only 10 meters, 23 meters, 80 meters. So now we are talking about 1 meter, sub-meter, like 45 centimeter, etc. So satellite means earlier only used for mono type of applications. Now satellite is also used for stereo imaging. So that means you can use two different dates or two different angle data and then get a three-dimensional view and then use it for a terrain application, generating a orthographic, what is that, ortho photo, and then generating ortho map that can be used directly for making maps, where you remove the relief and then use it, and then like that. So then you have a hardware like a workstation based to PC and then mobile level. You can use, like even a mobile also, you can use your GIS package for updating the files like a mobile mapping. And then you have a software like desktop based WebGIS and then mobile GIS. Mobile GIS, what is that? It is like a ArcPad or QPad or SuperPad. WebGIS softwares are all there specific to WebGIS, ArcIMS and Map Server, etc. Desktop is, you have a Quantum GIS and then IGIS, ArcGIS, etc. We will be talking about a PC-based, desktop-based software like a Quantum GIS, and then demonstrated later for all of the users. So then you have a internet like a low bandwidth and broadband. So it also plays an important role when you wanted to use a Google Earth, etc. And then there are a lot of web services, Google Earth and Whirlwind, etc. So now they are talking about how to bring in the street level information. Say suppose you wanted to go to new area and then find a house where you wanted to go. So then you straight away go to the street map